All right, guys. Number one, we're just going to do 1 through 19. That's enough for this one. Write in standard form. Okay, standard form means that you start with things, you have the x squared, and then you have the x, and then you have the number, and then you have to equal 0. That's the rules about standard form. That's the order. So we need the x squared guy to be first, we need the x guy to be second, we need the number guy to be last, and then over here we have to have 0. So this guy's just got to get moved over here. So we're going to move the 9x over to this side, which makes it negative 9x, and we're going to have 2x squared minus 9x plus 11 equals 0. We always want to equal 0 when we set up these equations. All right, number 3. Here we go. X squared minus 5x plus 4 equals 0. We're supposed to graph these. Okay. First thing I know, positive 4 is on this graph. Okay. Next thing I know is, can I factor this? Can we do what we were doing yesterday? Because then we'll find the zeros. We'll find when this graph equals 0. So if we have x squared minus 5x plus 4 equals 0, we can factor this. I need two numbers that multiply to positive 4 but add to negative 5. And the numbers are negative 4 and negative 1. So we have x minus 1 times x minus 4 equals 0. So these are called my two zeros of my equation. If I plug in 4 into this, this would be 0 times negative 3. If I plugged in 4 right here, that would be 0. So the whole equation would equal 0. So yeah, 4 does equal 0. So if I plug in 4, that equals 0. That's where 4, 0 is right there on the graph. If I plug in positive 1, that makes this side 0. So 0 times anything is 0. So 1 will make this equation 0. So that's right there. Okay, so now I've got some points. Anytime I have 2 points that are exactly sideways from each other, I can use those 2 points to find the middle. The middle must be right halfway between them, right here at 2.5. Ooh, what did I just do? Right here at x equals 2.5. So that's where the middle is. If that's the middle, I know that there's a spot right there. This guy must be opposite that guy if that's the middle. Okay, so the only last point I'm supposed to need, in fact, in this homework assignment, you really don't even need it. I just know that this is going to come down here, turn around, and go back upstairs. That's what I know. Okay, now, do I need to find that bottom point? Not really, but I know it's at 2.5, so I could plug in 2.5 into the equation, 2.5 squared minus 5 times 2.5 plus 4. And 2.5 times 2.5 is 6.25, I believe. 5 times 2.5 is minus 12.5 plus 4. If I do that all in my calculator, 6.25 minus 12.5 plus 4 equals negative 2.25. So if I plug in 2.5, I get negative 2.25, which is right about there. So yeah, it was pretty close to being right. What I needed to know was that these 2 points are the 2 spots where the second number is 0, where we equal 0, where we equal 0. So on a graph, the reason why this is standard form is you can really quickly look at a graph, and wherever it hits this the 0 line, those are your answers. So you can read a graph, and just wherever it hits the x-axis, that's the 0 line. So the 2 answers to this are x equals 4 and 1. We solved it using math right here and right here, but on a graph, that's what it looks like. These are the 2 spots right here, right there, and right there that we're looking for to solve the equation. All right, number 5. We'll go a little faster. X squared plus 6x equals negative 8. Okay, well, we need it to equal 0, so we got to throw that 8 to the other, negative 8 to the other side. So x squared plus 6x plus 8 equals 0. First thing we know, positive 8 is on this graph. Why does it keep going opacity halfway? Okay, positive 8 is on this graph. Right there. Next thing we know, we can factor this. We need 2 numbers that multiply to 8, so probably 4 and 2, that add to 6. Yep, 4 and 2. X plus 4, x plus 2 equals 0. So when does this thing equal 0? When this guy's equal to 0. If we plug in negative 4, we'll get 0. If we plug in negative 2, we'll get 0. So those 2 spots are on the graph. Negative 2, 0, and negative 4, 0. anytime you have two spots right across from each other, you know where the middle must be. That's why. You know where the middle must be. The middle must be right between those two spots. So the middle is at x equals -3. So then I know a point is right here because that's in between those two spots. So I know this graph is going to come down like this, hit this guy, keep going down, turn around, come up, and hit this guy. Do I need to find that spot? I don't think so, but if I wanted to find that spot, I could plug in -3 into the equation. -3 squared plus 6 times -3 plus 8 equals 0. I've got 9 minus 18 plus 8 equals 0. And I've got -9 plus 8 equals -1. So it was at -1 right there. Did I need to know that? No. The spots that I needed to know were that guy and that guy. Those was when the graphs equal 0, equal 0. So we could solve it using math. And then this is what it looks like on a graph right here. That's the big thing, that you know that the spot times that it hits theirs is when it equals 0. So x equals -2 and -4. Number 7, x squared minus 16 equals 6x. Well, we got to get this on the same side. X squared minus 6x, because we got to move this guy over here where he belongs, minus 16 equals 0. All right, I need two numbers that multiply to -16 that add to -6. So I need a positive and a negative, and I need them to multiply to 16, and I need the negative to win by 6. So the negative is 8, the positive is 2. That's how we do it. So we have x equals 2, -2 and 8. So x equals -2, that's right there. X equals 8, 1, 2, 3, 4, 5, 6, 7, 8. There we go. I know the middle now. The middle has to be halfway between them, so that looks like it's right there at 3. What else do I also know? I also know there's going to be this spot at -16. That's down here somewhere. So there's going to be a spot 3 away from it down there. So this thing's going to be way down here. Do I care exactly where? Not exactly. What I care about is the two spots where it equals 0. And we kind of got those. So the two spots where it equals 0 are right at -2 and 8. And that's what it looks like on a graph, where it hits the 0 line. Number 9. All right, x squared minus 6x plus 9. X squared minus 6x plus 9 equals 0. Okay, I need two numbers that multiply to +9 but add to -6. This one's kind of cool. It's the same number twice. -3 times -3 is +9. -3 plus -3 is -6. So whenever we have exactly the same thing, x minus 3 times x minus 3, like if we ever have 7 times 7, that's 7 to the second power. So anytime you multiply something by itself twice, you say that it's that thing to the second power. So this is x minus 3 times x minus 3, so that's x minus 3 to the second power equals 0. And the only thing that makes this equal to 0 is 3. Because 3 makes this one 0, 3 makes that one 0. So the only time that the guy's going to equal 0 is at 3. So 3 is the only time it equals 0. What does that mean? That means that this line cannot come back past the line because it has to come back up and it would hit again. But it's not allowed to hit again. Only one number makes this thing equal 0. So what does that mean? That means that this line, I know it hits 9 also, so right here. This line comes down, perfectly kisses the line just once, and goes back up. So it only hits the line once. It hits it perfectly and goes back up. That's what happens when you have the same number twice. It only hits the line once. So that's what that graph looks like. All right, number 11. Let's see, number 11. X squared plus 10x plus, or let's do that, equals -25. I've got to make it standard form. X squared plus 10x plus 25 equals 0. I move the negative 5 to this side, 25 to this side, it makes a positive 25. All right, I need two numbers that multiply to 25 and add to 10. So it's positive 5 and positive 5, which is just x plus 5 squared equals 0. So there's only one number again that makes this equal 0, and it's negative 5. If I plug in negative 5, I'll get 0. So negative 5, negative 1, 2, 3, 4, 5. I don't know why I hit the ground. Negative 1, 2, 3, 4, 5. Negative 5, 0. I know it goes up to 25, somewhere way up there. So this thing's gonna come down, perfectly touch there, and go back up all the way to 25. So the only thing I really care about is this spot. We know that it hits the line once right there at negative 5. So x equals negative 5. For this one, x equals 3. All right, number 13. Let's see. Number 13. All right, the negatives just turn us upside down. Negative x squared minus 14x equals 49. Here's what I do with negatives. Negative x squared minus 14x minus 49 equals 0. Okay, I can take a negative out. I can multiply both sides by negative 1, basically. I can take a negative out of here and just say this is negative x squared plus 14x plus 49 equals 0. So I've got this negative that I just took out. So I took a negative out of everything, which switched everything. Now I'm going to do negative. This is x plus 7 times x plus 7 equals 0, which is negative x plus 7 squared equals 0. So the only thing that makes this 0 is negative 7. So we'll put negative 1, 2, 3, 4, 5, 6, 7. And I know this thing turns upside down because the negatives, anytime you have a negative in front of the x squared, it's going to be an upside down u. So this thing is going to look like this. Do I care exactly where? Not really. I just need to know that it's upside down and it comes and touches the negative 7 spot just once. So x equals negative 7. 15. Yes, these are complicated. X squared minus 5x plus 7 equals 0. X squared minus 5x plus 7 equals 0. Okay, sometimes you can't factor these. Like right now, I got to think of a number that multiplies to 7. Well, just 7 and 1. But those numbers don't add up to a negative 5 anyway. So I can't factor this. So what do? I use some tricks that I can use. Let's see. I know this graph starts at positive 7. So there's 1, 2, 3, 4, 5, 6, 7. Okay. I've got a trick to find the middle. When I don't know two numbers I can plug in, I can find the middle. And it's negative b over 2a. Negative b is negative 5. So negative 5 is positive 5. Over 2a, the a is 1, so that's over 2. So the middle is at 2.5, which is right here. 2.5 is right there, right in between 2 and 3. So the middle's at 2.5. If that's the middle, I know that this guy must be right there too. Okay, so let's plug in 2.5. Let's figure out where this graph actually goes. So 2.5, because I know I want to put the vertex somewhere, and this vertex is going to be somewhere at 2.5, so I'm going to plug it in. 2.5 squared minus 5 times 2.5 plus 7. Well, let's see what that equals. 2.5 times 2.5 is 6.25. Minus 5 times 2.5 is minus 12.5 plus 7. So here we go. 6.25 minus 12.5 plus 7 equals 0.75. So if I plug in 2.5, I'm going to be at 0.75. So 2.5 is right here. 0.75 is like right there. So this hits there. What's weird about this if I graph it, comes down, hits there, goes back up. It never hits, it never hits this line. You see how there's space in there? This never hits the 0 line. There is no time where this is ever going to be 0. It never comes down and hits the line. It misses it and goes back up. So this is no solution. That's why you make these all equal 0. You can just really quickly tell, does the graph ever hit this line? If it never hits it, you see how it never hits it in there and just goes back up, stays positive, this is going to be no solution. If it hits it just perfectly once, there's one solution. And if it hits it like normal, there's two solutions. So sometimes there's two solutions, sometimes there's one answer, sometimes there's no answers when the graph never hits it. All right, let's go 17. X squared plus x equals -2. All right, let's make this equal 0. X squared plus x plus 2 equals 0. All right, so let's do what I can do. I know this graph starts at 2. Can I factor this? Let's see. A 2 and a 1 are the only numbers I can use to multiply to be 2. But I either need them, they're either both going to be negative, -2 and -1, or +2 and +1. Either way, if I add them, I get 3. If I add these, I get -3. Never do I get just 1. So there's no way to factor this that I know of. So if I can't factor this, I'm going to go look for the middle. -b over 2a equals b is 1, so -1. A is 1, so 2a is 2 equals -1/2. That means the middle is right here at -1/2 somewhere. Which, if that's the middle at -1/2, I know there's another dot right here because they're both on the same side, on the opposite side of the, equally from the mirror. All right, so where does this graph go? Does this graph ever hit the line? Well, let's see. Let's plug in -1/2, -1/2 squared minus 1/2 plus 2 equals 0. This is +1/4 minus 1/2 plus 2. You could say 0.2, if you like doing it in decimals, minus 0.5 plus 2. -0.25 plus 2 is +1.75. So if you plug in -1/2, you get 1.75. 1.75 is between 1 and 2, is like right there. So this graph comes down, turns around at 1.75 and goes back up. It never, ever hits this line. No solution. It never hits the 0 line, so it never equals 0. No solution. So you can tell looking at a graph right away, if it never comes down and hits that line, it's no solution. If you're confused, don't worry. Don't worry. We're going to go back to normal stuff here in a little bit. All right, 19. 1/2 x squared plus 2x equals 6. We got to make it equal 0. 1/2 x squared plus 2x minus 6 equals 0. Okay, a couple things I can do. All right, if there's ever something all of them share, I'm going to take them out. And I can take 1/2 out of all those numbers. So I'm going to take 1/2 out, which means I just have x squared. If I take 1/2 out of 2, actually I have 4, because 1/2 times 4 is how you got to 2. You actually make it twice as big. And if I take 1/2 out of -6, I actually have 12. -12 equals 0. All right, so I've got 1/2 times, and I can factor this, x plus 6, x minus 2 equals 0. So if I'm graphing this, this would equal 0 at -6 would equal 0. Okay, -6, -1, 2, 3, 4, 5, 6, and +2. I also know this thing, I also know this thing starts at -6. I know the middle is halfway in between those 2 points, which would be 2, 2, 1, 2, 2, which would be right there. At -2, there's the middle right there. So if that's the middle, there's a spot right there. I could plug in -2 into this thing and figure out what I get. 1/2 times -2 squared plus 2 times -2 minus 6. 1/2 of 4 minus 4 minus 6. 2 minus 4 minus 6 is -8. 2, 4, 6, 8. And there's my graph. Do I really care about all that much? Not really. What I really care about is these two spots, because those two spots tell me when it equals 0. That's when it equals 0, 0, 0. So the answers are x equals 2 and -6. All right, good enough for today. You should be super confused, but hopefully some of you, it starts to make sense, the processes that I'm doing. That's enough for today.